Hello friends, I am Vivek Kumar, Assistant Professor, Department of Electronics, Faculty of Engineering, Gurukul Kangadi Vishwavidyalaya, Haridwar. So friends, today we are going to discuss a Schmitt Trigger circuit. The circuit diagram of the circuit is shown here. So this is operation amplifier, basically connected in commutator mode. There are two resistors R1 and R2. And through these resistors there is a positive feedback provided to the operation amplifier through this pass to non-inverting terminal of the operation amplifier. This is Vi, voltage input connected through resistor R3 to the inverting terminal of the operation amplifier. So there will be some voltage at this point, that is at non-inverting point of the non-inverting terminal of the operation amplifier. So it may be this can be assumed as some potential VUT. So when the potential of this point becomes less than the potential of, sorry friends, this is fluctuating again. So when the potential of non-inverting terminal, this point, becomes less than the potential of inverting terminal, that is Vi, output will change, or as we know, if the VID, that is potential difference between non-inverting terminal and inverting terminals, becomes greater than 0, output will change to plus Vsat. And when this VID, that is potential difference between positive terminal, that is non-inverting terminal, and inverting terminal is less than 0, output will change to minus Vsat. So according to this theory, when Vi is greater than, when this Vi is greater than this potential, output will change. So let's say in a starting output is plus Vsat. So in a starting, let's say output is plus Vsat. So when the potential, that is Vi, is greater than this potential of this point, so it will directly change. So let's say output was starting output was plus Vsat, so it will change to directly to minus Vsat. In reverse case, when this Vi, that is input voltage, becomes less than voltage of this point, when this Vi becomes less than this point potential, output will change to plus Vsat. The second output in figure C. So when this was in starting, let's say output was minus Vsat in second case. So this was minus Vsat. So output will be going to plus Vsat. When the potential of this point, that is potential of non-inverting terminal, that is called VLT, becomes less than potential of input voltage, that is Vi. So I have redrawn here separately to calculate the potential of this point Vp. So this was Vsat in case of positive voltage output. This was V reference. So we can calculate using superposition theorem. So Vp can be calculated as Vp is equal to plus Vsat into R2 upon R1 plus R2, that is killing V reference, plus V reference divided by R1 plus R2 into R1 when Vsat is 0, that is killing Vsat. So we can calculate this potential Vp. So this potential is called VUT, that is upper trigger voltage, when Vsat is, that is V output is plus Vsat. So when V output is plus Vsat, when this V output is plus Vsat, the potential of this point Vp is called VUT, that is upper trigger voltage, and this is given here. By just applying superposition theorem we can calculate this. Similarly, when output V0 becomes minus Vsat, when V0 becomes minus Vsat, VLT, that is potential of Vp, is called VLT, that is lower trigger potential, and this can be calculated similar likewise as we have calculated above. So this is minus Vsat into R2 divided by R1 plus R2 plus V reference divided by R1 plus R2 into R1, killing Vsat, and in this case killing V reference. So the difference of these potential, that is VUT and VLT, is called V hysteresis. So V hysteresis is given here, that is VUT minus VLT, and it can be calculated simply. V hysteresis is equal to 2 times R2 upon R1 plus R2 into Vsat. Simply the difference of above 2, that is VUT and VLT. Now the need for this kind of trigger circuit is that when input voltage, because comparator is used in open loop mode, so if there is a small input change at input side, or if there is a small change in input because of some noise sources at output side, comparator will trigger. Comparator will simply trigger because because the open loop gain of operation amplifier is very high, so output will change directly irrespective of our requirement. But we do not want to change its input, that is output of we do not want to change its output, that is output of operation amplifier, due to this false triggering. So we can use comparator circuit as Schmitt trigger circuit to avoid this false triggering. So this is giving a final graph here. So when output was in starting, initially when output was plus Vsat, output was plus Vsat, it triggers at VUT, and when output was minus Vsat, circuit triggers and its output go to plus Vsat. So this is plus Vsat starting, this is plus Vsat, and if VUT arrives, output becomes minus Vsat, and when starting, if output is minus Vsat, it will change abruptly to plus Vsat, that is at VLT point. So output is changing, and this square shape is called V hysteresis. This square shape is called V hysteresis. So this is called V hysteresis, which we have calculated here. V hysteresis is equal to 2 times R2 divided by R1 plus R2 into Vsat. Now when V reference is 0, when we put V reference equal to 0, and if you apply a sinusoidal input voltage to input of the operation amplifier, that is Schmitt trigger circuit, we can obtain this type of output. So this is input sinusoidal voltage applied at input side, that is Vi, and accordingly this is its output voltage. So at VUT, in starting output was plus Vsat, so at VUT it will change, and it will change to minus Vsat up to VLT, that is lower trigger point. So it will remain minus Vsat up to lower trigger point, and at lower trigger point it will again trigger, and output becomes plus Vsat. it will again remain plus Vsat up to the upper trigger point, that is this point, and again it will trigger to minus Vsat, and the output will be triggering. So this is basically a wave shaping circuit, and the input sinusoidal wave will be changed into or transformed into square wave, similar square wave. So this is also called a Schmitt trigger circuit, used as a square wave circuit. In this case, VUT and VLT are equal and opposite in sign, and that is given as R2 upon R1 plus R2 into Vsat. So VUT, basically VUT is equal to minus VLT equal to Vsat upon R1 plus R2 into R2. So based on this, we can solve one numerical problem here. So referring to figure 5.9, that is in starting figure, that was this figure. In the starting figure, the values of R1 and R2 are given. So the value of R1 is equal to 56 kilo ohm, and value of R2 is 150 ohm. V input is 1 volt peak to peak sine wave of frequency 50 Hz. V reference is equal to 0 volt here, and operation amplifier is 741 used with voltage supplies plus minus 15 volt, and saturation voltage is 13.5 volt. You have to calculate its VUT and VLT and draw input output waveforms of the Schmitt trigger. Also plot the hysteresis voltage curve. So we can calculate VUT and VLT here from the formula. VUT is equal to minus VLT equal to Vsat upon R1 plus R2 into R2. So this is giving 36 millivolt. So VUT is 36 millivolt. VLT is also minus VUT, that is minus 36 volt. So this is the waveform, input waveform, and this is output waveform. So as soon as the sinusoidal voltage is below 36 millivolt, that is VUT, that is upper trigger voltage, output was minus Vsat. So output was minus Vsat. As soon as the input voltage becomes greater than this UT, that is VUT, that is after this point for this much span, the output becomes the output of a Schmitt trigger circuit will trigger, and it will trigger from plus Vsat to minus Vsat directly, and it will remain Vsat up to VLT, that is minus 36 volt. So at minus 36 volt, it will again trigger, and it will again trigger to plus Vsat. So it will trigger from minus Vsat to plus Vsat, and again after this point, for similar reason, after this point it will remain plus Vsat up to plus Vsat up to VLT. So at VLT, when the input becomes greater than this VLT, output will change. So output of a Schmitt trigger will again change, and it will be changing to minus Vsat. It will change to minus Vsat from plus Vsat, and this will be repetitive. So the hysteresis can be calculated here. The hysteresis is given as V hysteresis equal to VUT minus VLT. So hysteresis voltage can be calculated, and the output waveform is explained here. So when output was plus Vsat, so output of a Schmitt trigger will change when input is greater than, or input becomes greater than VUT. So it will change directly to minus Vsat. Again for the same reason, when output was minus Vsat, and if input is becoming lower than minus VLT, so output will change to plus Vsat in this fashion. So this is a square shape. So V hysteresis is given by VUT minus VLT. So this was the explanation of a Schmitt trigger circuit. Thank you friends, thanks for watching.